GeoGebra tutorial. We continue with the lines. The third way of introducing the equation of line is line at an angle theta and intercept on y-axis as C. Standard equation is y is equal to x multiplied by tan theta. See, we have to enter this theta either in radians or in degrees. Let me put this as pi by 3, that is 60 degrees. And we want some intercept on y-axis. Let's say the intercept is minus 3. So we got this particular line at y is equal to x tan pi by 3 minus 3. Y is equal to mx plus c is the equation. Now this is the preview. When you enter, the line will be fixed, and in the algebra window you will get the equation in the form y is equal to mx plus c. Now other form of equation that may be that we have some intercept on x-axis and maybe some angle is there. So we again put that y is equal to, now here we have got x minus the intercept, that is, let's say 1, okay, and tan, let me put a negative angle this time. So I have maybe minus pi by 4. So 45 degrees minus angle. And this is again a preview. So I enter this and we have got the other line. See, here you have got this intercept as 1 and slope is minus 1, that is tan 45. Okay. Now if you have 2 points and you want to pass a line through that, then what you have to do is you have to take 2 points at will somewhere, maybe in this fashion, and then you take this line tool, put it in A and B here or here also. So this third equation you get is with A and B, you see that ax plus by is equal to some constant is the equation of this third line. Okay. In addition, it's possible for you to put a line in the form of some equation. Okay. So maybe you put some equation ax plus by is equal to c. Okay. So maybe 3x minus 2y plus 3. Okay. So you will get some equation, okay, with this particular. See, here I got this particular thing, multivariable function test said. Okay, so this is how you put the lines. Okay, now what we do is we have this. It's better to write y on one side, so we say 3. That 3 you can take on the other side. Okay, so you have got y is equal to, okay, I put this like this. So you have got 3x plus 3 and divided by 2. So this is the equation here. Okay. So because we have put this mixed thing, the computer does not accept this as a line. Okay. But if you separate these variables, you get this particular line. Okay. So in this way, it's possible for you to generate these lines. Now what we do is we go ahead and see how we have other types of lines, that is, perpendicular line, parallel line, tangent line, perpendicular bisector, angle bisector. All these, let us see how these lines are obtained. So for this, I have 2 points here and I take some line and say that I want a perpendicular line from A on this particular line which is already there. Okay. So for that, we have here a tool for perpendicular line. We click on that and you will see that it says select point and perpendicular line. So in this sequence, we have to select that. This is known as tooltip instruction. So we click this, click the point and click this line here, or you may click it here. So please see that you have got this particular line perpendicular to it. Now to check whether this is perpendicular, it's possible for you to measure this angle. So we have to get angle between these two lines. So please see that we have got this particular angle to be 90 degrees. It's a perpendicular line. Okay. Now let us see how we draw a parallel line. Again, what we do is we go here, pick the tool, and tooltip instruction is select point and a parallel line. Now supposing I am interested in drawing parallel line to this line through point B. So again see, select point B and select the line. Okay. So click this. So I got this parallel line. Okay. So we can have parallel line, we can have perpendicular line. Right. Now, in order to study the perpendicular bisector, we must have some segment. So I'll remove these lines and then I take a segment. So segment tool is there. I take the segment C and D. Okay. And then what we do is we take the tool for perpendicular bisector and then just click on this segment, you will get perpendicular bisector for that. Okay. So it's so easy. So you got the perpendicular bisector here. Now if you want angle bisector line, so we should have a line first. So I take this line. This is the angle. Let me put the arms for that. Right. Now, if you want this angle bisector, we take this. Again, we take the tooltip instruction, that is select 3 points or 2 lines. Now here we have got these points A, D and B. So in that sequence you have to write. That is, the point representing angle should be in between the two. So we click A, we click D and we click B and we have got the angle bisector. Okay. Now many times we have to draw the tangents also. So let me remove this junk from here. Okay, and delete this. Okay, and maybe I delete the segments also. Okay. Now here I am interested in the tangent, so I must have a circle or some other conic. So I take this circle, maybe here, and then I am interested in drawing tangent to this circle from some point which is external to this circle. Then we have a tool here for tangents, and we click, see, tooltip instruction, select point or line, then circle, conic or the function. Okay. So we click here and then circle here or maybe conic here. We have got these two tangents. Okay. Now if you are interested in checking whether this is at right angles to that, what we do is we take either the cutting points here, maybe then we have a cutting point tool. Okay. So what we do is we click this and click the circle. We got that point, click this and the circle, we got this point, and then I join the radius. And I am interested in seeing whether this is 90 degrees. So for that again I take the angle tool, E, G and A. Okay. So this is how it's possible for you to draw the tangents. Okay. Now one more line tool is available which we like to see. So before that I just remove this junk from